It was the best vacation planned. For months, we had planned to visit Cusco, Machu Picchu, the top Peruvian attractions. It's a place where my family hadn't had a chance to visit before. For my father, it would have been a chance to revisit. My mother, my brother, we had a great time. That was 2005. Fast forward 10 years, things changed completely. My father was turning 93, and at that time, he was in a hospital bed, impacted by Alzheimer's disease, a disease so pernicious that actually destroys the brain of a person. Complete change. Why do I mention this? Look at the impact of this type of disease. A person could be not feeling any symptoms, but eventually, step by step, progressively, and as of now, unavoidably, the brain is being destroyed by this disease. Why do I mention this today? Because artificial intelligence can actually help not only the patients, but also the families. If you had a person in your family impacted by Alzheimer's disease, you should know how painful it can be, how difficult it can get at the end of that time for a person with you. Why AI? AI can help you understand when symptoms that still are not noticeable for a physician can actually be identified through imaging, either a CAT scan, an image that AI could look at and recognize initial symptoms of what Alzheimer's disease is going to be. Only when you're going to start this diagnostic early, medication can work. My father was diagnosed very late in the game. No medication would have reversed or even slow down the progression of this disease. However, there is hope. There is the hope now that AI can help identify the disease at such an early stage that current medication or eventually new medication to be developed will be able to help and will be able to slow down the progress of this disease. There's just one example of how artificial intelligence can give you hope, can give you a solution to a problem that is still hard, impossible to solve. We achieved a milestone. The milestone was for a machine to be able to defeat the master champion in chess, Garry Kasparov, in a series of matches. That was, at some moment, impossible to imagine. People thought this is not going to be a feat that's going to be achievable in our lifetimes, but it happened. In a series of 6 matches, Garry Kasparov was defeated by Deep Blue. In the first match, Garry won. The second match, the machine won. 3 matches were drawn. And then in the last match, the computer was able to defeat the master in chess. Of course, Garry Kasparov didn't think it would be possible. He thought maybe the machine had some human support. IBM said, no way, it was the machine. And we believe it. That's a step in the right direction. Is that intelligence? We'll have to discuss that today. Look at this picture. What is it? All of us don't even need to think to tell us that this is a wheel. How can you teach a computer to know that this is indeed a wheel? By definition, a wheel is going to be a circle. And we don't have a circle here. We have an oval, we have ellipsis, however you want to call it. But that's not a circle. So how do you teach a computer to recognize that you have the wheel of a car in this image? Only through training. This is not a circle. The line might not be perfect. The angle is not 90 degrees, as we would like to see in a picture. So therefore, a computer will have trouble if you see an image like that has not perfect lighting, the angle is not clear, or there's something obstructing the view. A computer won't be able to recognize that. However, if you're able to train a machine with millions of these images, a computer eventually will be able to capture the key features of a wheel and eventually give you a result that could achieve 99% of success. That will happen through training over millions and millions of examples, and then developing a model that will be able to handle hundreds of parameters to define what's going to be the result. Compare that to a human. And let me bring my little girl, Svetlana Sofia, to the picture here. She went to the zoo, and she learned that this animal, this tall animal with long legs, it's called a giraffe. She didn't need to know the name, but she recognizes now a giraffe. So I don't have to teach her anything else. Next time we go to the zoo, she will know that this tall animal, yellowish, with black or dark spots, it is the same type of animal she saw before. She learned with one data point. While a computer might need hundreds, thousands, or millions of data points, a human, us as babies, only would need one data point to be able to recognize that this animal belongs to the class giraffe. Of course, she will know the name much later, but nonetheless, she now can recognize this using one data point.